Hi and Assalamualaikum. My name is Emilia Alika binti Rudi. So now I will discuss about activity 1, which is electrical power measurement in a DC circuit. So okay, this is the circuit for simulation. This is DC voltage, and then this is voltage, ammeter, voltmeter, and RL. So the resistance is the cumulative, which is 100 to 500, and the simulated voltage we need to search, and simulated current as simulated power. So this is the circuit. So first we need is AC voltmeter, AC ammeter, and voltmeter, and then R1 is 100. So we need to run and get the result of AC voltage, which is 59.9, and then AC ammeter 0.60, and then voltmeter is 35.9. So we stop, and then we change R1 to 200. Okay, and then we run. So we get the answer for, we get the value for AC voltmeter, which is 60.0, AC ammeter 0.30, and then voltmeter is 18.0. So we stop, and then we change it again to 300. Okay, and then run until we get the value of AC voltmeter, which is 60.0, AC ammeter 0.20, and voltmeter is 12.0. And then we stop, and then change it again to 400. Okay, so run. Okay, we get we get the answer for AC voltmeter, which is 60, AC ammeter 0.15, and voltmeter is 9. So stop, and then change for the last value, which is 500, and then run. Okay, so the value of AC voltmeter is 60.0, AC ammeter is 0.12, and voltmeter is 7.2. And then we stop run. Okay, and then we full the table, and then the calculated power and calculated power pical minus 3% error was calculated manually. So this is the calculation. Okay, so P calculation is simulated current times simulated voltage. So for the first, we go with RL equal to 100, Pical 0.60 times 59.9 equal to 35.64 watt. So we move to second RL, third, fourth, and fifth. So we need to search the Pical minus 3% error. First 3% error, which is 3 divided by 100 and times 35.64, we can get 1.0782 watt. And the answer, we must times 35.94 to get the Pical plus 30 minus error, which is 37.02 watt. So this is the next step, the same step. So this is the circuit, and so that's all from me.
Hello, my name is Ilmi Abdul Hakim bin Saruddin with the matrix number of AE2037, and here I will be explaining to you our data sheet. So here we have the list of our resistor value. For each resistor, we give it one alphabet. This is so we can make our sample. So as you can see in sample 1, we have our alphabet using my name, Ilmi Abdul Hakim. Resistor value of each of them and the sum of it is down below. And here we have sample 2. Alphabet is Eli Ardila with the following resistor value and the sum. And we have the last but not least our member 3, sample 3, which is Emilia Eleka, resistor value of the following with the sum of 750.8. For the first graph, we have the sample 1. We can find the mean, which is 68.3, the minimum, which is 68, the median 68.3, maximum, which is 68.7, the average deviation, which is 0.14, rounded off to 2 decimal points, standard deviation 0.19, and for that we have our table, which is the cluster interval for each of the resistor value from 68.0 all the way to 68.7. We have our frequencies on the right, each of the frequencies, and from that table we can have our graph. As you can see, this is our distribution for sample 1. Same goes for sample 2. We have our mean, our minimum, median, maximum, average deviation, standard deviation. We have our table for each of the resistors and our frequency for every resistor there is in the sample, and this is our distribution table. And this is for sample 3. We have the mean, the minimum, median, max, average deviation, and standard deviation. We have the class interval, the table, the frequency, and our graph. And that is it from me. I will now pass over to our next member. Thank you very much.
Hi, Assalamualaikum. My name is Edi Adila binti Nasaruddin. My matrix number AE190074. So I will explain for activity number 3, which is electrical power measurement in an AC circuit with capacitive load. So we look at the lab sheet. We need to create a circuit connection shown in figure 6.4 in the simulation software. So this is the circuit connection that we have the capacitance here. So we move to the simulation circuit. We have the sign, we have AC voltmeter, we have voltmeter with VA, and we have voltmeter with watt, and also we have resistor and capacitance. So for this experiment, for this activity, we need to remain the value of resistor, but we need to change the value of capacitance. First, we start with 2 microfarad until 10 microfarad. So I set here 2 microfarad. So we need to run. So after we run, we look at the wattmeter value result, which is VA is 3.14 and wattmeter is 0.20. So next, we change value of capacitance with 4 microfarad. So for microfarad, we got value of VA is 6.24 and the value of wattmeter is 0.78. So next, for value of 6 microfarad, we just need to change the value of capacitance and run the simulation until 10 microfarad. So for 6 microfarad, we got 9.26 for VA, and then for wattmeter we got 1.72. So next, for 8 microfarad, so after we run, we got value of VA is 12.2 and value of wattmeter is 2.97. And next, for the last one is 10 microfarad. So value of VA is 15 and value of wattmeter is 4.49. So we move to the table. So at here we put all the result, and for the calculated power factor, which is PF, we just need to use the calculation, formula calculation, which is we need to find the XC, and then we need to find the impedance, which is Z, and then theta, and then last one is power factor. So for the power factor, the formula is true power or real power over apparent power. So for the real power and apparent power, we just get from the table, simulated apparent power and simulated real power. So just get this value and use the formula until we got the result. So for the first load, which is resistor with 100 and capacitance is 2 microfarad, we got calculated power factor is 0.06, and the last one until load of 100 ohm of resistor and capacitance is 10 microfarad, we got calculated power factor with 0.30. So that's all for the activity 3. Thank you. Okay, next I will explain for activity number 4, which is electrical power measurement in an AC circuit with inductive load. So from the lab sheet, we need to create a circuit connection shown in figure 6.5 in the simulation software. Okay, so this is the circuit simulation connection. So if we look at this circuit, we have inductive. So for the simulation, we just need to change the previous circuit, which is activity 3, that we use inductance. We use capacitor before, so we need to change to the inductance. Okay, so same with activity number 3, we need to remain the value of our load resistor with 100, and we need to change the value of inductance with 0.002 Henry until 0.01 Henry. So look at the simulation circuit. We use 2 microfarad in sync with the 0.002 Henry. So we run the simulation. We got VA is 50 and wattmeter is 50. And then for the next value is 6 microfarad. We just need to run. And we got the value of VA is 50 and value of wattmeter is 50. Okay, then for the next is 8 microfarad. We got value of VA is 50 and wattmeter is 50 also. And for the last one, which is 10 microfarad. Same, the value of VA is still 50 and the wattmeter is still 50. So move to the table, we need to calculate a power factor, which is PF. So this is the result that we got, simulated apparent power and simulated real power, which is all the value are 50, VA and wattmeter. So for the calculated power factor, we just need to use this formula. Real power factor PF is equal to power real over power apparent. So example for first load, which is 100 ohm plus 0.002 Henry, the simulated apparent power is 50 and simulated real power is 50. So we just need to key in to the formula 50 over 50, so we got 1. So for the calculated power factor, all the loads is same, which is 1. So that's all for activity number 4. Thank you.